Today we're going to talk about 7-5, using proportional relationships. Before we actually begin, we have a warm-up. What we want to do is convert 6 feet 3 inches into inches. So essentially we want to get rid of these feet. Now you should be able to do this, but as a reminder, obviously the inches is already good. We don't need to do anything with that. But 6 feet, well, we've got to do something with that to get rid of the inches. Or to get it into inches. Well, to do this, what I would do is we're going to multiply by, well, how many inches are in 1 foot? Because we're going from feet to inches. So we're going to say that there's 12 inches per 1 foot. Or in other words, what's going to happen is that the feet are going to divide out or cancel. This is going to turn out to be 72 inches. And now we just need to add these 3 inches back in there. So plus 3 inches, which gives you 75 inches. So converting that gives you 75 inches. We will be doing that a lot in this section. All right, applying that warm-up to an example, let's go ahead and use an indirect measurement to find the length of a flagpole if a 5' 6" student measured the respective shadows as follows. Now, what exactly is an indirect measurement? All it is simply any way to find how big something is without actually measuring it. Such as if we set up proportions. That would be an indirect measurement. So, go ahead and doing this. Big key here, especially in this section, you want to recognize what units you're in. We're in feet and inches here. So you want to convert everything to the same unit of measurement. And I would say inches would be the easiest. So we need to convert all of these into inches using the strategy we did in the warm-up. So again, how we do this is we take that, let's say 5 feet, and we convert this to inches by multiplying by 12 inches over 1 foot, which gives you 60 inches. And I've gone ahead and put in our actual measurements in inches in all of these. And to find the height of here, we need to set up a proportion. We know these are similar triangles, and so what he did was he measured his own shadow here and the flagpole shadow. And so let's go ahead and set up proportions knowing that these are similar triangles. We have, well, what is the length of his shadow? It's 60 inches over the length of the flagpole shadow is 170 inches. We know this will be equal to the length of the man, which is 66 inches. Notice that both measurements dealing with the man are on top. The 66 and the 60 are both on top. That's what you want. And then both on bottom is the flagpole, which we don't know what that is. So let's go ahead and call that X. And we could have put the flagpole both on top or both on bottom, as long as the flagpole and the man are consistent. And now to solve this, we need to cross multiply. We do 60x is equal to, multiply those big numbers, and you're going to get 11,220. Dividing by 60 then gives us x is equal to 187 inches. Now we have our answer, which is 187 inches, but we originally started in feet. So our original problem dealt with feet and inches. So we need to try to change this into feet. How do we do it? Well, we do the reverse of what we did before. So we have 187 inches times, well, we know that there's going to be 1 foot over 12 inches. In other words, we need to divide by 12. So 187 divided by 12 is going to give you 15 feet and a remainder. It's not an exact number, so I saw that it's a decimal. It's like 15.57. So since we have it in feet, we still need a few inches because we know there's a remainder. So simply, what is that 15 times 12? We're going to see how much of a remainder it is. 15 times 12 is 180. So we had 187, and now you need to subtract that 180 to give you 7 inches. So it's 15 feet and that's 7 inches of a remainder. So our answer is 15 feet, 7 inches. You have done most of this before, probably in middle school or Algebra 1, so hopefully it's coming back to you on that. One applicable application of the proportional relationships of what we're talking about are scale drawings. Now you should know what scale drawings are by now. It basically just represents an object as smaller or larger than its actual size. One very common scale drawing is a map. So on a Wisconsin road map, Kristen measured a distance of 11 and 1/8 inches. The scale of this map is 1 inch to 13 miles. What was this distance in miles to the nearest mile? So what this scale tells you is that for every single inch on the map, it represents 13 miles in real life. And on this map, Kristen measured 11 of those inches, 11 and 1/8 inches. And so we want to know how many miles is that? Well, since it's 1 mile, or since it's 1 inch is 13 miles, and we have 11 of those inches, why don't we do 11 times 13, which will give you 143. So we know for sure it's going to be at least 143 miles because of the 11 times 13. 11 inches, and for each inch, there's 13 miles covered. Now we have a little bit more, which is 1/8. So all we have to do now is, well, what is 1/8 times 13? 1/8 times 13 will give you 1.625. Now we just need to add up these two numbers to give you 144.625. Well, our question asks now to the nearest mile. So we need to round this up because our 6 is bigger than a 5. So we give about 145 miles is the distance that she measured on the map. We do have one theorem for this section, and it's Theorem 7-5-1, Proportional Perimeters and Areas Theorem. So if the similarity ratio of two similar figures is A to B, then the ratio of the perimeters is A to B. And the ratio of the areas is A squared over B squared. So let's go ahead and use this theorem in an example here. We know that triangle ABC is similar to triangle DEF, and that BC is equal to 4 millimeters and EF is equal to 12 millimeters. If the perimeter is equal to 42 millimeters, and the area is equal to 96 squared millimeters just in triangle DEF, we're going to find the perimeter and area of triangle ABC. So to do this, it's always easier to look at some triangles. So we can just draw any triangles we want here. I mean ABC and DEF, but we don't necessarily know what they're going to look like. So I'll go ahead and draw these. Now we have A, B, C, and D, E, F. Of course, it should be said that these drawings are not to scale. I have no idea if DEF is going to be bigger or smaller. I drew it smaller, but it was just because. So we know that BC is equal to 4 millimeters, and EF is equal to 12 millimeters. Oh, it looks like it's going to be bigger anyway. Okay, so now it simply says that if the perimeter is so-and-so and the area is so-and-so, then find the perimeter and area. Well, we can use this theorem directly. It says that if the similarity ratio of two similar figures. So we know that these two are similar, so let's find the similarity ratio. Meaning, let's do, what we're going to compare is triangle ABC over triangle DEF. So anything with ABC is going to go on top, anything with DEF is going on bottom. Now it doesn't have to be that way. You could have done the other way as long as you stay consistent throughout. But I just chose ABC over DEF. So the only really lengths that we know are 4 and 12. So let's set it up. We know that ABC is going to be 4 and DEF has a side of 12. This is going to reduce down to 1/3. So this here is our similarity ratio. Now I'm going to go ahead and change colors now. It says that if the similarity ratio is AB, so we know that this is our similarity ratio, which is in the form of AB again. Means that in this case, 1 is A and 3 is B. Then the ratio of the perimeters is A to B. So when we compare perimeter now, we know that it's going to be 1/3 will be equal to, it's going to be proportional to 1/3. Let's see, do we know the perimeters at all? Well, yes, we know the perimeter of, if the perimeter is equal to 42 for triangle DEF. Now remember, we have DEF on bottom. So we don't know the perimeter of ABC, but we know this perimeter will be 42. So to find that x, just simply cross multiply. 42 is equal to 3x. Therefore, x is equal to 14 millimeters. And thus that your answer is 14 millimeters. Now for area, very, very similar. Area is equal to. Now the only difference here is that it says that if the similarity ratio is AB, then the areas have a similarity ratio of A squared over B squared. So instead of saying 1/3 right here, we need to square both of those numbers. We need to say 1 squared, which is 1, over, what's 3 squared? Well, it's 9. And we know that this is going to be equal to, now we set up that proportion. We have ABC on top. Do we know the area of ABC? No, so let's just go ahead and call it X. And it's over the area of DEF, which is 96. Again, go ahead and cross multiply. X is equal to 96 over 9. Or in other words, if you were to reduce this, it's 32 over 3 millimeters squared. And so now we have found the area and perimeter. The big key here was knowing to square your similarity ratio for the areas. So besides that, that's all we've got for today. Hopefully it should be somewhat of a review, but if not, be sure to write down any questions you have and ask in the morning.